All right, so anyway, you guys have two of these reference tables, okay, and this is for, and this message is for those people who are watching online. If you lost or you did not get a reference table, they are available under the Week 5 module. You can download and print out your own copy. You will need these two tables, which are Table 2 and Table 3. Table 2 is the standard normal cumulative probabilities, and Table 3 is the binomial probabilities. You will need to bring them next week for the midterm exam, okay? There's one more table that's included in the reference tables online, but you won't need that. That's the T table. That will come later on in the course, and I'll pass those out as well. But so anyway, just bring, oh, sorry, this, bring table 2, which is the normal cumulative probability, and table 3, which is the binomial probabilities. Okay, to midterm exam. You'll need, of course, you'll need your calculator. Also, bring your calculator. Bring an ID, photo ID. Okay, this is, I know it sounds silly, but there were incidents in the past, so now I have to make everybody bring some kind of photo ID, okay? And then, I don't want to make it awkward, but if you forget your photo ID, I'm going to have to take your picture, and later on you'll have to verify that you are you, okay? So don't be offended that this might happen. So just bring your photo ID, and then we don't have to deal with any of this awkwardness, okay? But so if you forget, I will take your picture. Okay, so please bring your ID, and then of course pen, pencil, eraser, whatever.
Are we allowed to have a note card?
Oh yes, yeah, you get a note sheet, one note sheet. Yeah, so that is going to be 8.5 by 11, or letter size. Writing on one side only. The midterm is next week. We're going to start at 7 o'clock, and you guys have, it'll be 2 hours.
Do we leave afterwards?
Yeah, afterwards you're done. Okay, so the midterm is 2 hours, and then leave when done. How many questions? 10,
20.
No, it's more than that. Yeah, in the vicinity of about 50, 40 to 50. Okay.
Is it the same as all the practice quizzes?
It's not the same, but I would say studying the practice quizzes is a good way to study, okay? And of course, and I would say the practice quizzes would probably cover 90-something% of the exam, and then there's going to be a few questions that are outside of the practice quizzes, but that's it. Yeah, probably, from the homeworks and lectures, yeah, okay? But I'd say the practice quizzes will cover about 90% of the exam, yeah. Yes?
Does the note sheet have to be handwritten?
It does not. It does not have to be handwritten, but it has to be your own creation, okay? You can't, one person making a note sheet and then photocopying it for a bunch of people, okay? So it has to be your own thing. If you wanna type up your own note sheet, that's fine. If you wanna, like, I don't know, whatever else you wanna do, that's fine. But it has to be your own work, yes.
Do you consider it needed to get a good grade?
A note sheet? No, I mean, I could do this without a note sheet, and I'd be fine. So it depends on who you are, right? So some students will do fine without a note sheet. It's happened plenty of times in the past, and then other students like having a note sheet. So I can't say who wants and who doesn't need a note sheet. Yeah.
So these problems that you put up online, would they pretty much cover the stuff outside of practice?
No. Those. Okay. So you know. So I'd say to study. So to study. Okay. Start. I would say study. Study the practice quizzes and practice. Practice quizzes. Okay. And then I'd say between the practice quizzes and then I have like a fake practice quiz from this chapter, okay? Because you don't have a quiz next week, right? You have a midterm next week. So I've said like if you have, practice quizzes and then, this week's practice problems, right? Study practice quizzes and chapter 6 practice problems. And yeah, they're all in the modules. So I'd say this covers about 90% of the exam, all right? And then, the rest I would say either come from the homework or lectures. Yes?
You do not need a Scantron?
I will provide the Scantron for you, okay? It looks like this, but with more questions, so.
It can just look like that. That's fine.
Well, then every single question will be worth like 3% of your grade, and I don't think you want that either, right? So, yeah, that would be much more stressful. So, you have more questions. Yes.
So next week is the midterm, and then a week after that there's no quiz.
Yeah, there's no quiz during week 7. Okay, so next week is week 6. So you have the midterm exam. Week 7, there's no quiz because we wouldn't have covered anything new. Okay.
So then the week after that, which is week 8, is covering for chapter 7.
Yes. So week 8. So now we're talking about like the distant future, right? Week 8 there will be a quiz, and that will cover the stuff that we covered in week 7. Okay. All right. Okay. I think. Is that good? We're all good, right? Okay, so let's cover chapter 6. Well, you can buy Beyonce's album on iTunes now, okay? Like you can just pay $18 and get it, and you get the also on Amazon. So.
You can't keep mentioning Beyonce. You're not even going to give any regard to if Jon Snow is alive or dead.
Hey. All right. Veep started up ours also anyway. That's okay. Anyway. All right. So let's talk about probability distributions. So this is a little bit of it's a little bit different because we're not talking about data directly, okay? The data is very much involved, but here we are dealing with kind of random values and kind of these theoretical probability distributions, okay? So with a probability distribution, we have these are, my pen just froze on me. Hang on a second. These are basically theoretical shapes, okay, that tell us how data, quote unquote, should be distributed. Okay? And so, for example, we're going to very much learn about the normal distribution. Okay? And the normal distribution looks something like this, okay? And so along the x-axis is basically a number line, okay? So along here we have a number line, okay? And the height of this curve represents how common these values are. Okay, so for example, I could put the value 100 in the middle, and because the curve at 100 is as tall as it gets, this means the value 100 would be the most common value in this distribution. Okay, so the curve is the tallest at 100, okay? And so this means values of 100 are most common. I could say this is 80, and I can say this is 120, okay? And so if I go over to 120 and I go over to 80, okay? In terms of height, they are about half as high as 100, okay? So the curve at 80, right here, regarding the height, it's about half as high as it is at 100, right?
So if 80 was where 100 would be, that would be the most common value.
Correct, correct. So what this means, so the curve at 80 is about half as high as the curve at 100. Okay, so that means the values of 80 are about half as common as values of 100. So for every time you see an 80, there's probably 2 values of 100 out there. Okay, does that kind of make sense? All right, and then so, you know, values down here like 60 or values up here at, 140, these are even more rare, okay? So 60 is even less common. Is the concept of some kind of a probability distribution okay with you guys? Okay, so it's kind of this a shape, and so the norm, we're going to look at the normal distribution, which has this kind of nice hill shape, but we could have other distributions. So for example, I could have a distribution that looks like this. Okay. So this one would be called uniform. And what does this shape tell us? All the values here are equally common, okay? Or all the values between 0 and 1 are equally common, and then all values outside of that just don't appear, right? So what this says is all values between 0 and 1 are equally common. Okay, and then values larger than 0 don't appear. Or I'm sorry, larger than 1, and values smaller than 0, values less than 0 don't appear. Okay, and perhaps in a a more advanced statistics or probability course, you would learn all of these other shapes. You would have like shapes that look like this, and all the other skewed and exponential and all of this stuff. These types of things would appear, but we're not gonna. I would say these are beyond the scope of the course. Okay, so these other shapes exist, but are beyond the scope of this course. Okay, and again, these are just theoretical shapes that say this is kind of how our data should be distributed. Okay, so if we had on the previous page, we had this, it's saying basically if the data follows this shape, values of 100 should be twice as common as values of 80, etc., etc., etc. Okay, so this is kind of a theoretical guide on how common or uncommon certain values should be, and we can kind of do analysis based on that. Okay. Okay, so let's go back to our normal distribution. Okay, which looks something like this, okay? And the idea here is that if we were to shade the entire thing, the entire area underneath the curve is equal to 1. So the entire area so again, this is our normal distribution. So the entire area under the curve is equal to 1, okay? And then if we're talking about the standard normal, okay? If this is a standard normal, the value that goes in the middle is 0, okay? So which means we have positive values to the right, negative values to the left, okay? So if I were to draw a vertical line at 0, and I shade in everything to the left, okay, how much have I shaded? 0.5, right? So we draw a vertical line at 0. Shade everything to the left. Okay, the amount shaded is 0.5. Is that okay? All right, and we can look this up in our standard normal table. Okay. So if you pull out table 2, the standard normal table, okay, and you flip it to the side, I don't know, this side, okay, in the top left corner you're going to see 0.0 and 0.00, and it will say Z, something like this, okay? In the top left corner you're going to have this. All right, and the very first number in that top left corner is 0.5000. Okay, so that basically says, you know, if you take 0.0 and you stick on 0.00, so you have, if you draw a line at 0.00, so if you draw a line, and we would say line at z equal to 0.00, which is basically what I have here, because I can throw on trailing zeros and it doesn't affect the value, right? If I draw a line at 0.00, the area to the left is 0.5000. Okay, is that all right with everybody? Okay, let's say I move just a tiny bit to the right, okay? So I'm gonna actually make a new slide here with something like this, okay? Now I'm gonna go just a tiny bit to the right, and instead of drawing a line at 0.00, I'm gonna draw a line. I'm going to draw a line at 0.07, okay? So 0.07, and we're going to shade over here, okay? So now we're going to draw a vertical line at 0.07, okay? We're going to shade everything to the left of 0.07. How much will I have shaded to the left? Okay. Well, we're going to look this up in our table. Okay. And so to get 0.07, I'm going to go to the row 0.00, but I'm going to go to the column 0.07. Okay. And so this will be 0.07. And what is the value that it says there? 0.5279. So that this total area, the amount shaded is 0.5279, which makes sense, right? Because before, when I drew a vertical line at 0, I had 0.5. Now that I've moved just a tiny bit over to the right, I've added a little bit more. And so now the amount I have shaded is 0.5279. Yeah, question? Okay, well, so we're looking up the value 0.07, right?
Oh, 0. Oh, okay, I never mind.
Okay, so the first two numbers, I mean, if we can parse this out. The first two values are 0.0, and then the last digit is 0.07, or is 7. So that corresponds to, so this breaks up into 0.0 and 0.07. Okay? Is that okay with everybody? All right, so if I have 0.5279 over here, if this area over here is 0.5279, how much is over on this side? Okay, all right, so what is that number? 0.4721. Yes, 0.4721. Okay, so this area is 0.4721, and I got that by doing 1 minus 0.5279. Okay, is that all right? So if we asked what is the probability that a value from the standard normal is less than 0.07, our answer is 0.5279, okay? Let me write this down. This doesn't like my, okay, so I'm gonna write, what is the probability that a random value from the normal distribution, I should say from standard normal distribution, is less than 0.07, our answer is 0.5279. Okay? Because we're saying, according to the normal distribution, when I draw values less than 0.07, I'm going to have a probability of 0.5279 that it's coming, that it's going to be less than 0.07. Okay? And on the other hand, I could say, what is the probability that the random value is more than 0.07? So that would be the area to the right, and that would be 0.4721. So what is the probability that a random value is more than 0.07? And our answer there is 0.4721. Does that feel okay? Kinda? Yeah, question.
So no matter what, when there's a normal distribution and it's a perfect shape, the area under it is always going to be 1?
Yes. Okay. Then no matter what, if it's a normal distribution, the area under it is 1. Okay? And in fact, this table will work for all normal distributions. And not all of them will be standard normals, but I'll show you how to go from a non-standard to a standard normal, and we'll talk about that. But I just want to make sure we're okay with this stuff first, then we'll try using this table a little bit more with the standard normal, and then we'll apply it to I guess other problems. Okay, so we're feeling good here. Okay, so let's just try a few practice. Standard normal practice, okay? And so I'm going to draw a couple shapes here, and you tell me how much I have shaded. Okay, so both of these are supposed to look identical here, but so both of these are standard normal, okay? And whoops. Don't you hate when that happens? Okay, so the question is, how much did I shade? How much is shaded? Okay, so I'll give you guys a couple minutes to figure this out. You're going to use your table. So I've got 1.24 and negative 0.53. And if you're on YouTube, I'm going to pause the video here to give you a chance to figure these numbers out yourself. Okay, so as you guys are working, some of you are asking, how do I look up this number here? Okay, so for the number 1.24, look at, what are the first two numbers? Or, I mean, what's basically, yeah, we've got 1.2, and we have a 4, okay? So in the table, what you're going to want to look up is you're going to go to the row 1.2 and the column 0.04, okay? Does that make sense? All right. Okay, so if I do that, what number do I find there? 0.8925, okay? Is that my answer? No, it's not. It's not, right? Because if we look at our picture, let's look at our picture, okay? The entire area is 1, right? The entire area is 1. Is this more than half of the entire area? No, the shaded area is certainly not more than half. And so when you look something up in the table, it always gives you the area to the left, okay? So we have 0.8925 to the left of 1.24. So what this means is the area to the left of 1.24 is 0.8925, okay? But how much do I have shaded? I'm going to have 1 minus that, which is going to give me what? 0.1075. 1 minus 0.8925 is 0.1075. So how much is shaded? This answer is 0.1075. So the shaded area okay, so remember, the table will always give you the area to the left. Okay, table always gives you the area to the left. Okay. All right, what do we have for the other shaded area here? Yeah, okay, so we're going to go to the negative side of the table, okay? And we're going to go to what row? The row negative 0.5, right? 0.5. And we're going to go to column 0.03. And when we do that, we find 0.2981. Okay? Is that my answer? And the answer is yes, this is my answer. Okay, this is, the table gives us the areas to the left, and that's exactly what I want. Okay, when I look at the picture, I want the area to the left. So the answer I want is 0.2981. No, you always have to look at the picture, okay, and say, am I shading to the left or am I shading to the right, okay? If I'm shading to the left, I take the value that the table gives me, because the table always gives me the area to the left. But if I'm shading to the right, I don't take the value that the table gives me. I take that value, I subtract that value from 1, and I get the area to the right. Is that okay? Do we need more practice, or are we feeling okay?
So pretty much if it's on the right, it's always 1 minus whatever that number is. It's the shaded
Correct, correct. If we're looking at the area to the right, it's always going to be 1 minus whatever it is we're looking at. Yeah, another question. And if it's the area to the left, it's the area that you look up in the table. Okay, huh? All right, so we'll do just another pair of practice problems. Okay. Okay, so both of these, what is the shaded area? Okay. Okay, how are we doing? I'm getting 0.8849 here. And over here I have 0.8508. Okay, so if we didn't get that, let's look. So we're going to go to 1.2 and 0.00, and that's 0.8849 in the table, and that's exactly what we want. Okay, over here we're going to go to negative 1.0 in the column 0.04, and I get 0.1492. Okay, and then, but that's not what I want. I want the area to the right is going to be equal to 1 minus 0.1492, which gives me 0.8508. Questions? Yeah.
So it doesn't matter if it's on the left side of the 0, it's just the left side.
I'm sorry, your question again?
Like if you shade the left side of the whole thing,
Mm-hmm.
it doesn't matter, it doesn't have to be like on the left side of the 0.
Right. It doesn't matter if you're on the left or right side of the 0. The table will always give you the area to the left. Okay? The table will always give you the area to the left. All right. Is this okay with you guys?
Yes.
All right. Let's try something else out. Okay? So here. All right, so here I'm going to tell you can you guys see that? So it says the shaded area is 0.6772. Okay? The question is, where did I draw my cutoff? Okay, do we have an answer here? Okay.
406.
Okay, so when I'm going to find 0.6772, I find that this is in the row 0.4, the column 0.06. So my cutoff is at z equal to 0.46. Okay. Is that okay with you guys? So here, so this time I gave you the area, and I'm asking where I drew the cutoff, okay? Now, sometimes the area that we give you will not have all 4 digits, okay? So it might look something like this, and it'll be something like, we'll say this area is 0.34. Okay, so now again, where is the cutoff? So the shaded area is 0.34, okay? And where is the cutoff? Do we, so the shaded area is 0.34, and we'll just say, or at least very, very close to it. So maybe not exactly 0.34, but very close to 0.34. And where is our cutoff then? Okay. How are you guys over here doing? Good? Maybe? We have a value? So I know some of you guys have it. So I look in the table, and the value I find that's the closest is 0.3409. Another value is close, and that's 0.3372, but 3409 is the closest, and that corresponds to the row negative 0.4 and the column 0.01. Is that okay? And so our cutoff is at z equal to negative 0.41. Is that okay with you guys? Questions? You guys have to feel comfortable with all of this stuff. Yeah.
So if we're given a question with a z-score, would the area that we're looking for be shaded?
So, okay, this is, I will not give you questions directly like this, okay? This is kind of the building, one of the steps in the question. So the questions that I'll ask will actually be different, but you have to understand this in order to do those other questions, okay?
The reason why I'm asking is because for the previous slide,
Yeah.
when we put the question, I don't think you shaded the area we were looking for, so I wasn't too clear as to what area we were looking for, if it was to the left or to the right.
On the previous slide, I just said, what is the shaded area? So in these questions, I've drawn the picture and I said, what is the shaded area? And part of these problems that we'll look at is you've got to be able to draw your picture, shade in the side, and then use that as a way to get your answer, okay? But in these cases, so we'll do one more of another pair of these, and we haven't really actually gotten into normal model problems, but we're just getting comfortable using the normal table first, okay? All right, so here is where is the cutoff is the question. And I'll draw a little picture here. Okay, and so I'll go through these. We're asking, where's the cutoff? Where's the cutoff? All right, so let's we'll take a look here, and let's just address a few things, okay? So remember, in these pictures, what's going to go in the middle? We're going to have 0 in the middle, right? Okay. So we know for this one, our answer has to be greater than 0. It has to be positive, okay? And we also keep in mind that the table always gives us the area to the left. Okay? And so we're not going to be looking up point 2. I mean, I'll say something about this at the end, but we're going to actually look up 1 minus point 2, which is the area to the left is 0.8. Okay? And so we're going to look up, we're going to try to find the area that is closest to 0.8. Okay, and if you look in the table, the area that's the closest to 0.8 is like 0.7995. Is that right? Okay. There are other values that are close, but 0.7995 is the closest to 0.8. Okay? And so 0.7995 corresponds to 0.8 in the row 0.8 and the column 0.04. Okay? And so that means our cutoff is at z equal to 0.84. Is that okay? Now some of you guys might have gotten negative 0.84, okay? And the reason for that is you've probably looked up 0.2, okay? And the picture there corresponds to this side being shaded to be 0.2, okay? And because it's symmetric, you would get negative 0.84. But a negative answer would not make sense because if you look at our picture, our cutoff is definitely to the right of 0. So we should definitely have a positive value, right? So we're going to have z is equal to positive 0.84. Is that okay with everybody? Okay. Yes, a question?
Where did you get 0.8 from?
0.8? So here, if the area to the right is 0.2, this shaded area is 0.2, okay? And everything has to add up to 1. What is this unshaded area going to be? 0.8, right? Does that make sense? Okay, so we just want to make sure that these two sides together add up to 1. And so we have the shaded area is 0.2, the unshaded area is 0.8, okay? And we actually want the unshaded area because we want the area to the left. The area to the left is what we're looking up, so we're going to look up the thing closest to 0.8, and that's 0.7995, okay? So using that, what are we going to look up over here? We're not going to look up 0.92, we're going to look up 0.08, exactly, okay? And when we look up 0.08 in the table, we also know we're below 0, so we also know our answer has to be negative, right? So we're going to be on the negative side of the table, and we're trying to find the thing that's closest to 0.08. Okay, area closest to 0.8. Okay, and when we do that, you know, we find a couple of candidates that seem pretty good. Okay, I have 0.0808. That seems pretty close, and I also have 0.0793. Both of these seem pretty close. Okay, I would say that 0.0793 is closer. Okay, this is only 7 ten-thousandths away, whereas this is 8 ten-thousandths away. So this one is closer, and that corresponds to negative 1.4, and the column is 0.01. So our cutoff at z equal to negative 1.41. So, you know, I always ask, is this okay? And a lot of you guys kind of nod your heads. And as I was walking around, definitely there are a lot of you who are, like I saw the work you did, and you are doing well, okay? Or, you know, maybe you found positive 1.41. Okay, that's a common mistake or understandable mistake, and you just have to keep in mind that you're always looking the area to the left. So that's great for you guys. But as I was walking around, I also saw people, for lack of better words, just don't seem like they're trying out these exercises that I have you guys do as a class. So, you know, I take these pauses so you guys can kind of test and make sure that you understand this. So, you know, please be responsible for your own learning and education here. Okay. Anyway, we're going to take a 10-minute break here, and then we'll come back and we'll apply this to some problems.